Hi everyone, welcome back to my channel Root to Mathematics. In this video, going to solve this interesting equation. So here we have given, solve this equation, and the equation is 2 to the power x plus 8 to the power x equals to 130 in real number system. Okay, so here we are asked to solve for the value of x in real number system. So let's get started. So what I have given, we have given 2 to the power x plus 8 to the power x equals to 130. Okay. In the next step, we have 2 to the power x plus, here I can write this 8 as we know that 2 cube is nothing but 8. So I'll write it as 2 cube. So 2 cube whole to the power x equals to 130. Okay. Now we know an exponential rule, that is a to the power m whole to the power n is equals to a to the power n whole to the power m equals to a to the power mn, means the power get multiplied and also we can interchange the places of power. So by applying this rule, here we can write 2 to the power x plus 2 to the power x whole cube equals to 130. Okay, now let us assume 2 to the power x equals to y. Okay, now I'll substitute 2 to the power x as y in the next step. So this implies is y plus y cube equals to 130. Now this implies is, now taking this 130 to the left hand side and rearranging the equation a bit, we have y cube plus y minus 130 equals to 0. Okay, so here we have a polynomial and here we need to find out the roots of this polynomial. So in order to find the root, we'll apply here a rational root theorem, that is possible rational roots equals to factor of the constant divided by the factors of the leading coefficient. Suppose here we have a polynomials x cube minus 4x square plus x plus 6. The constant of this polynomial is plus 6. So the factors of plus 6 are plus or minus 1, 2, 3 and 6. Okay, and the leading coefficient, here is our leading term whose coefficient is nothing but 1. So the factor of leading coefficient is plus or minus 1. So the possible rational roots can be plus or minus 1, plus or minus 2, plus or minus 3 divided by plus or minus 1. So here we are getting possible rational roots as plus or minus 1, 2, 3 and 6. Okay. So we'll apply this rational root theorem in this polynomial as well in order to find the possible rational roots. So for this polynomial, the constant is minus 130. So the factors of 130 are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 13, plus or minus 65 and plus or minus 130. Okay, this is the factors of 130. Now the factors of the leading coefficient, here the leading coefficient is 1 as well. So the factors of leading coefficient is nothing but factors of leading coefficient is equals to plus or minus 1. Okay. Now we need to find out the possible rational roots. So the possible rational roots is equals to, we need to divide these factors with 1. If I divide the 1 with all the factors, we will getting the same factors. Okay. So the possible rational roots are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 13, plus or minus 65 and plus or minus 130. Okay, now we need to test for which value the given polynomial is satisfying. Okay, so our equation is is y cube plus y minus 130 equals to 0. If I take y equals to positive 1 or negative 1, the value cannot be equal to 0, as one value of 1 is very less. Same goes with 2. 2 will be also very less. 2 to the power 3 will be 8. 8 plus 2 is nothing but 10. 10 minus 130 cannot be equal to 0. So these two roots get discarded. Now we'll take for y equals to 5. For y equals to 5, y 5 cube plus 5 minus 130. This equals to 5 cube is 125 plus minus 130. 130 minus 130 equals to 0. So y equals to 5 is satisfying the equation. So y equals to 5 is one of the solution. Now the next root is plus or minus 13. This will also not satisfy. Same goes with plus or minus 65 and plus or minus 130. Okay. As we know that y equals to 5 is one of the root, so we can divide our polynomial y cube plus y minus 130 with y minus 5 in order to find out the other factors of the polynomials. So for that we'll use the long division method. As we have y minus 5 as a divisor, so in the quotient I will take y square. So y multiplied with y square will get same as y cube. So here we'll write y cube, again minus 5 multiplied with y square. Here we have minus 5 y square. Here y cube is positive, so we'll take negative here. Here negative, we'll take positive here. So y cube minus y3, these two get cancelled out as this negative sign became positive. So here we'll write 5y square plus y minus 130. Okay. In order to cancel this first term, we need to take plus 5y in the quotient. So now y multiplied with plus 5y is 5y square, and minus 5 multiplied with plus 5y minus 25y. Okay. Same, we need to take the opposite sign. Here negative will take positive. So these two get cancelled out, and here we are getting 26y minus 130. So here we'll take 26 y multiplied with 26. Here we are getting 26y minus 130. Negative, and here we have positive sign. So these two get cancelled out, and here we have 0 as our remainder. So here we are getting a quadratic equation, that is y square plus 5y plus 26. So the polynomial equation y cube plus y minus 130 equals to 0 can be written as y minus 5 multiplied with y square plus 5y plus 26 equals to 0. Okay. Now from here we know that y equals to 5 is one of the solution. Okay. Here we have a quadratic equation. In order to find out the value of y, we need to put the quadratic formula, that is y equals to minus b plus or minus root under b square minus 4ac divided by 2a. Here a is 1, b equals to 5 and c is equals to 26. These are the coefficient of the above quadratic equation. Okay. Here we know that b square minus 4ac is the discriminant of this quadratic formula. This represented as d, which is equals to b square minus 4ac. Now we'll put the value of a, b, c here. So 25 minus 4 multiplied with 1 multiplied with 26. This equals to minus 79. Okay. So here we are getting discriminant as a negative value. Now by putting this negative value under the root, we'll get a complex or imaginary roots for the y. As in the question it is given that we need to find out the real roots. So the complex root get discarded. So in the real number system, only y equals to 5 is valid. Okay. Now, as we have taken y equals to 2 to the power x. Okay. Now we'll put the value y as 5 2 to the power x. Now here, in order to find the value of x, we need to take log both sides. So log of 5 equals to log of 2 to the power x. By using logarithm power rule, that is log a to the power n is equals to n log a. So applying this rule here, we can write x log 2 equals to log 5. This implies is x equals to, by cross multiplication, we have log 5 divided by log 2, which is equals to log base 2 5, which is approximately equals to 2.322 is the value of x. That's it for today. Thanks for watching. I'll see you in the next video. Thank you.